Hello, I'm MeshCentral, and in this technical video, we're going to take a look at mesh agent tunnels. One of the important parts of MeshCentral's set of features is remote desktop, terminal, and files. And that requires that the browser be able to talk to the mesh agent in order to exchange data through the server. And so in this video, we're going to take a look at how that happens in a little bit more detail. So I'm going to start with a set of slides here. And we are going to start by just an overview of what is an agent tunnel. So you have your browser on the left side right here, you have MeshCentral, and you have your agent or your remote computer on your right side. And so both the browser when you log in and the agent when it logs into the server, they set up these WebSocket tunnel, or not tunnel, but control connections. And so those are used for control purposes. They're used to exchange basic data about those devices or that browser, or that user, and also send commands back and forth. But usually they're not used for a lot of data, except maybe for the agent when it does self-update. But otherwise, the control channels are used for messaging. They're not used for bulk data transfer. Now, for data transfer, when we're talking about files or remote desktop, well, we need to set up a separate tunnel between the agent and the browser. So how do we do that? Well, what we're going to do is tell the agent and the browser a URI that they both must connect to. And they're going to connect to this URI separately from their control channel. So they're going to make a WebSocket connection to this URI called the meshrelay.ashx, which is just an arbitrary name. And what we're going to do is, once we receive both of these connections, one from the agent and one from the server, from the browser, the MeshCentral server will basically pipe them together. They'll hook the two pipes together, and so that the browser can talk directly to the agent. Now, the way permissions works is that when this tunnel is set up, the server will tell the agent, here's the user that wants to set up this tunnel, and here's the permissions that that user has. So obviously, if the user has read-only access or doesn't have input access on a remote desktop or things like that, then the agent will block those features from the browser. But otherwise, the browser has sort of a direct connection through the MeshCentral server to the agent, and that's how it's done. So when you click connect on the UI, it will, for a very short time, it may say setup. And what happens there is that the browser will connect to the server, and then the server will wait for the other connection coming from the agent. And once the other connection is done, both the agent and the browser will get notified that the other side is connected. And so then the setup will switch to connect. So that is how that works. I'm going to demonstrate this actually. So I have my trusty MeshCentral server right here with a bunch of devices. I am going to click on a device, and I am going to go to desktop. And what I'm going to do is open the developer tools of Firefox. So when you click connect here, what you'll notice is that there is this remote desktop obviously that shows up. But if you go on the network tab of the developer tools, you'll notice that the browser made a connection to meshrelay.ashx and with a bunch of parameters here. And obviously the parameters are all checked by the server, so you can't just set up a tunnel to any machine. You can only set up tunnels to the machines you own. But if I say disconnect and connect, disconnect and connect, you'll see that every time there's a new WebSocket connection that gets created. And when I click disconnect, it just drops that connection. Okay? So that is how this works. And by the way, the same happens for terminal. So you'll see here terminal. And the difference is, instead of P2 here for protocol number 2, which is the desktop, it will say P1, which is the terminal. Or if I go to files, it's actually P5 in this case, and you see the file file relay gets set up. So that is what that does. Okay, so I want to go back to the slides and kind of explain the reasoning as to why we have a separate control connection and tunneling connections. So why do we have like a WebSocket for messaging and a WebSocket for bulk data, and why are they separate? And everything has to do really with, well, one is simplicity, but the other big one, and probably the most essential one, is flow control. So when the browser talks to an agent, the link speed or the connection speed between the browser and the server may be faster or slower than the link speed between the agent and the server. So maybe you have a fast link over here, but a slow link over there. And so what happens is that if you're sending a lot of data, the temptation is to send enormous amounts of data, and then the server won't be able to send it to the agent as fast as you can send it to the server, because this is faster than this one. Actually, a more common problem is when you have the agent that's faster than the browser. So when you do remote desktop, there's a lot of bitmaps for the remote screen. And so those bitmaps get sent over, and they're fairly bulky. And so you have these bitmaps being sent to the server. If the server can't send them to the browser fast enough, it could pile up on the server. So you get this constant flow of data, and if the server cannot flow control the data, then it will pile up on the server. So what this mesh relay does is it connects the two pipes in such a way that that if it can't write data into the path forward, it will hold the path backwards. It will apply what we call back pressure. And so it does that in both directions. And the beautiful thing here is that that can be done separately and completely independently of other tunnels that this browser or this agent may have, and it can be done completely independently of the messaging channel or the control channels. So you can have this be flow control, stop, start, because there's the slow link here, for example, but still these control channels will work perfectly because they're not subject to the flow control that this tunnel has. And the reason why I've opted for this approach is because there's an older version of MeshCentral. I called it MeshCentral V1, and it's now defunct. But in the old version of MeshCentral, what I would do is have the tunnel connection go over the controlled connections. So the agent and the browser would open tunnel connections or control connections to the server, and then we would bulk data, send bulk data over those control connections. And that was an absolute nightmare when it comes to flow control, because now you're taking this control connection and you're sending possibly multiple sessions, maybe 1, 2, 3 different remote desktop terminal files. You're sending messages, and you're doing that all over a single connection here. And so the flow control is very, very difficult, because if you have multiple browsers, talking to this agent, the agent may be able to send very fast to the server, but some of these connections on this side may be slow. And so now if you are not careful, what will happen is that you'll either pile up data on the server, or you'll have to hold all the connections. You'll have to stop everything here until the slowest browser gets its data finally transmitted, and then you can unhold this, or you can do it with a very complex flow control protocol. And so that has never been implemented fully on the MeshCentral 1. It was absolutely a nightmare, extremely difficult to implement correctly. And so that approach was abandoned. And so it's much better in MeshCentral 2 to have a separate connection for each of the tunnels here. So you have one agent, multiple tunnels, doesn't work, it doesn't matter. Each session gets its own flow control. So I hope that's clear. It's a basic basic topic for computer science and networking. So now I want to talk, now that we've understood a little bit how this tunneling work, I want to talk about three like odd cases or variations on the tunneling protocol. So one of them is WebRTC. WebRTC is a protocol that allows the browser to talk directly to the agent. We have in the agent a WebRTC data stack that it doesn't do audio or video, it only does data. But if you're able to do this, to set up this channel, and by the way, this channel is over UDP, then what happens is that you can bypass going through the server. Now imagine if the browser and your device, your target device, are maybe both on your home network. Well, normally the data has to go all the way to the server and then back to your device. But if you have WebRTC set up, then the browser can talk directly to the agent, and so that's very, very fast. So how does this get set up? Well, what we do is we always first set up the mesh relay. So we start by setting up the relay the way we normally do it. We give a URI to the browser, a URI to the agent. They both connect to the mesh relay. We pipe these together, and data starts flowing. Now, WebRTC may not always be able to get set up. There may be some network obstacle or stuff that doesn't allow WebRTC to get set up. So we start by transferring data through the server all the time. Then what we do is, as that's going on, we immediately send what we call WebRTC offers and responses, and we try to negotiate this WebRTC channel. And if we're successful, then we switch from sending the data back and forth through the server channel, we switch to using WebRTC. And so a trick we use in MeshCentral to do this is that we assume that binary data, so by the way, WebSockets have a string type and a binary type. So you can send data as a string type or as a binary type as a flag to identify one or the other. So we actually take advantage of that. If you send binary data, it's assumed that this is like KVM, terminal, file stuff. But if you send a string, a block of string text, then we assume that this is control data. So it's control data, but not over this control channel. It's control data over the relay. And so what the browser will do is, for example, it will send keystrokes in binary format, and the agent will send KVM data back in binary format, but at the same time it will use the string format to send the WebRTC offers and candidates and responses. And then if they're able to send WebRTC, set up WebRTC, then the browser will send a string command saying, I'm done using this channel. And tell me when you got this message, so I'm going to switch over to using the other channel. And so the browser will send that message. The agent will say, okay, I got the message that you're done using this. And then the browser will start using WebRTC. And then the agent will do the same. The agent will notice the WebRTC setup. It will say, I'm done using this channel. The browser will answer, okay, I got it, you're done using this channel, and then the agent will start using WebRTC. And the reason we do this is because we want the stream to stop and start perfectly correctly. Like, we don't want any overlap in the data, or we want the data to be one continuous stream as it switches from this channel to that channel. And so, of course, the stop and the stop ACK are in string-based commands, but the data that we send over here or over there is binary. So I hope that made sense, but that's how we negotiate the WebRTC, and that's how we switch from the normal tunnel to WebRTC. And because WebRTC is not always available, instead of using a turn server, we basically use the mesh relay like a turn server, and we don't negotiate turn servers, if you guys know what that is. Anyway, another variation on the agent tunnel is the desktop multiplexor. So if you have a browser that connects to the relay URI, but it just so happens that desktop multiplexing is turned on and the request is for a remote desktop, then the desktop multiplexer will send a command to the agent, have the agent connect to a URI, but instead of having the relay just pipe the two connections left and right together, here the desktop multiplexer will act as a man in the middle, basically. It will get the data from the agent, it will store the necessary bitmaps to cover the screen, and it will send that to as many browsers as possible on the left. So the protocol is exactly the same, except that, and the browsers actually don't really know. They think they're connecting to a mesh relay. The agent thinks it's connecting to a mesh relay, just like before, except that it's a special mesh relay that specifically implements the remote desktop protocol and does the multiplexing. So that's how that works. Otherwise, the protocol is the same. Lastly, I want to talk about a local relay. So that is when your server is in LAN or hybrid mode. So you are managing devices on your local network of the server. And so you have maybe a device here that has SSH or RDP or something like that. And you want to do an RDP session to that device. And there's no agent on that device, right? So the server can directly initiate a connection to do an RDP session onto that remote device. So what you do is you open the browser, you get your control connection, you say, I want to RDP to that target device over here, and it will say, okay, and it will send you a URI, but the URI will actually be not to mesh relay, not this URI here, but to local relay, and local relay will basically accept the connection, and then it will launch a local connection to the device. And if it's successful, it will tell the browser, okay, I'm successful, I got the connection, and then you act as a relay here. Of course, this relay does not have any control data. You can't send any string, only binary. And you have to send data that is exactly compatible with the protocol that you're targeting. So SSH or VNC or RDP are the ones that are supported with MeshCentral today. So anyway, I hope that was clear. Basically, the agent tunnels are a foundation of how MeshCentral works. They're really important. And maybe as you configure your MeshCentral server for Nginx or other things or firewalls, you'll understand why when you click connect on the remote desktop, you get these extra WebSocket connections from the agent and the browser. Anyway, thank you very much. Have a great day.